For this edition, I'm going to show you how you can use Cycling 74's BEAP analog synthesis and control modules in your Vizzie patches. I'm going to start with a very simple Vizzie patch that includes a player module connected to an effects module, a pixelator in this case, connected to a viewer module to display the results. I've also included a fader controller module that lets me manually adjust a parameter, in this case, the vertical pixelation of the final image. I'll start by adding a BEAP module. For this example, I'm going to work with a voltage-controlled low-frequency oscillator as a control source. To start, unlock the patch by clicking on the lock icon in the patcher toolbar. Click on the BEAP icon to display the BEAP browser, navigate to the LFO tab, and click and drag on the CV LFO to add the LFO to the Vizzie patch. The front panel of the CV LFO has an indicator that visually shows the LFO at work. Nothing's happening though. Well, that's because we haven't enabled audio in our patch. To do that, click on the button in the lower right-hand corner of the patcher toolbar to turn the audio on. When you do, you'll see the dials start to rotate. BEAP modules are designed to model various modules used in traditional analog synthesis. They send and receive number values at audio rate that emulate voltage values used with analog synths. 0 to 1, -1 to 1, 0 to 5, and -5 to 5. You'll even find those values labeled as voltages on the inputs and outputs of some BEAP modules. The LFO in this patch has two outputs that output two different number ranges. The signal outlet on the left sends -5 to 5 number values, and the ramp output on the right sends a ramp signal between 0 and 5. I'm going to use the ramp output of the LFO to control part of our Vizzie patch. All Vizzie modules that generate or send control data, like our fader, send and receive floating point values in the range of 0 to 1.0. So in order to work with Vizzie, I'll need a way to convert those output values to data in the range that Vizzie expects. There's a special Vizzie controller module created for just this purpose. It's called the BEAP converter. To add a BEAP converter module to your patch, click on the Vizzie icon to display the Vizzie browser, navigate to the Controllers tab, and then click and drag a BEAP converter into your patcher window. Since we're going to use the LFO's ramp output, we'll connect the ramp outlet to the BEAP controller's audio input. Finally, I'll connect the left output of the BEAP converter to the fader and then lock the patch. Look at the fader. Something's going on. It's moving all right, but it doesn't look like a ramp. That's because I haven't told the BEAP converter module which output range I want to use. It currently assumes it's going to be working with data in the default -1 to 1 range, which corresponds to standard audio. To set the module so that it outputs the proper range, click on the BEAP converter module's menu and choose the 0 to 5 range. The LFO's ramp output is now smoothly outputting ramp values based on the LFO's output. You can also use the BEAP converter module as a way to convert audio output to Vizzie data. To do that, I'm going to need an audio source. To add one, I can unlock the patch, click on the audio icon in the patcher toolbar to display the audio browser, and then click and drag an audio file into the patcher window to create a Max playlist object. Next, I need to disconnect the BEAP converter and the LFO. I'll click on the patch cord that connects the LFO to the BEAP converter module and hit return to do that. For the time being, I'll move the LFO aside since I'll be using it again, and then connect the output of the playlist object to the BEAP converter module's audio input. Last, I'll lock the patch, click on the circle icon in the playlist object to enable looping, and start the audio playback. When I do that, you'll notice that the fader module is moving, but the range of output is really small. Again, that's because I need to set the proper output range for the BEAP converter. Click on the BEAP converter's menu and select the -1 to 1 range, which is what we use for standard audio. Once that's reset, you can see that I've got a great way to use an audio source to control Vizzie parameters. You can also use Vizzie modules to control BEAP modules as well. In order to do this, it's necessary to do the opposite of what the BEAP converter does. That is, we'll need to have a module that converts Vizzie floating point data to an audio signal output in one of the ranges the BEAP modules work with. For that purpose, we'll use a controller module called the Vizzie converter. To show you how that works, I'll need to unlock the patch and do a little cleanup first. I'll click and drag to select the playlist object and hit return to remove it from our patch. I'm going to use that LFO module again. This time, I'm going to use Vizzie data to set the module's output frequency. I'm also going to use the BEAP converter and fader modules I had before as well. First, I need a source of Vizzie data to control the LFO. For that purpose, I'm going to use my old friend, the Navier-Stokes-based attractor generator module. To add one to the patch, I click on the Vizzie icon, navigate to the Generators tab, and then click and drag an attractor module into the patcher window. I'll also add a Vizzie converter module by clicking again on the Vizzie icon, navigating to the Controllers tab, and then clicking and dragging a Vizzie converter module into my patcher window. I can connect any of the attractor module's outputs to the input of the Vizzie converter object, but I'll use the first one. The Vizzie converter object takes floating point Vizzie data in the range of 0 to 1.0 and maps those values to continuous audio rate output values that emulate each of the audio output ranges that BEAP modules use. Since the CV input to the LFO module expects to work with audio input in the range of -5 to 5, I'll connect that outlet to the CV inlet of the LFO. To display the LFO's output, I'll once again connect the ramp output to the audio input of the BEAP converter and then lock my patch. Now, there are two more things I need to do. I need to reset the BEAP converter module to work with the 0 to 5 output range using the module's menu. In addition, I also need to set the CV-LFO module's CV amount parameter so that the low-frequency oscillator's frequency will be set using input from the Vizzie converter module. To do that, I set the CV amount parameter all the way up to 100%. The result is that the attractor module is now controlling the frequency rate of the LFO and converting that output to Vizzie data values. Vizzie to BEAP, and then back to Vizzie again. So there you have it, some brand new ways to think about working with Vizzie. Until next time, happy patching.